everybody again. So today we're going to learn about the universal sets and the complements. The universal sets, the complements, the unions and intersections, and the subsets. Let's start. Universal sets. The following sets all have a number of things in common. All three are contained within the set of whole numbers. They are also all contained in a set of integers less than 22. When dealing with sets, there is usually a largest set, which contains all of the sets that you are studying. This set contains according to the nature of the problem you are trying to solve. Here, the set of integers contains all elements from M, N, or O. But then, so does the set of all positive integers less than 22. Both these sets, and many more, can be used as a universal set. A universal set contains all the possible elements that you would consider for a set in a particular problem. The symbol E is used to mean the universal set, but it's this E, okay? Not the normal E kind of E. It's the curly E. Complements. The complement of the set A is a set of things that are in E but not in the set A. The symbol not A is used to denote the complement of set A. For example, if E equals 1, 2, 3, 4, 5, 6, 7, 8, 9, and F equals 2, 4, or 6, then the complement of F would be not F, 1, 3, 5, 7, 8, 9, and 10. So in summary, E represents a universal set, and not A represents the complement of set A. Unions and intersections. The union of two sets, A and B, is a set of all elements that are members of A, or members of B, or members of both. The symbol R is used to indicate union. So the union of sets A and B is written A or B. The intersection of two sets, A and B, is a set of all elements that are members of both A and B. This symbol AND is used to indicate intersection. So the intersection of sets A and B is written A and B. For example, if C is 4, 6, 8, and 10, and D is 6, 10, 12, and 14, then C and D is a set of all elements common to both, are 6 and 10. And C or D is the set of all elements that are in C or D or both, which is 4, 6, 8, 10, 12, 14. Subsets. Let the set A be the set of all quadrilaterals, and let the set B be the set of all rectangles. A rectangle is a type of quadrilateral. That means that every element of B is also a member of A, and therefore B is completely contained within A. When this happens, B is called a subset of A, and it is written B in A. The symbol is can be reversed, but this does not change its meaning. Subset of means B is a subset of A, but so does this. If B is not a subset of A, we write B is not a subset of A. If B is not equal to A, then B is known as a proper subset. If it is possible for B to equal to A, then B is not a proper subset, and you write B is not a B is not a proper subset of A. If A is not a proper subset of B, we write this. So in summary, R is a symbol for union, and is a symbol for intersection. B is a proper subset of A, indicates that B is a proper subset of A. B is a subset of B indicates that B is a subset of A, but is also equal to A. which is not a proper subset of A. This indicates that B is not a proper subset of A, and this indicates that B is not a subset of A. Here's example 6. If W is 4, 8, 12, 16, 20, and 24, and C is 5, 8, 20, 24, and 28, what's the set? W or T? W and T. Is it true that T is a proper subset of W? So the set of all members of W or of T or of both is 4, 5, 8, 12, 16, 20, 24, and 28. W or T is the set of elements that appear in both W and T, which are 8, 20, and 24. Notice 5 is in T, but 5 is not in W. So it is not true that every member of T is also a member of W. So T is not a subset of W. Exercise 9.8. A is 2, 4, 6, 8, and 10. And B is 1, 3, 5, 6, 8, and 10. What's the elements of A and B and A are B? So the elements of A and B are 1, 2, 3, 4, 5, 6, 8, 10. And the elements of E and B, the element of E, A, and B is 6, 8, and 10. And the elements of A or B is 1, 2, 3, 4, 5, 6, 8, and 10. Find n of A and B, and find n of A or B. So the answers to these are 3 and 8. C equals A, B, G, H, U, W, and Z. And D equals A, D, U, V, W, X, Y, and Z. What's the elements of A and C and D and CRD? So the elements of C and D are A, D, U, W, Z. And the elements of C or D is A, B, G, H, U, W, X, Y, Z. Is it true that U is an element of C and D? Explain your answer. Well, yes, it is an element of C and D. Is it true that G is not an element of C or D? Explain your answer. So G just needs to be in at least one of the sets, and G is then an element of C and D, C or D. So G is in both sets, which means that G is an element of C or D. So no, G is an element of C and D. It's not true. Question 3. F equals all the equilateral triangles, and G is all the isosceles triangles. Explain why F is a subset of G. So it's because all the equilateral triangles have at least 2 equal sides. We don't count the other side. What is F and G? Can you simplify F and G in any way? So F and G is just F and G is just what is it again? F and G is just uh, F. Question 4. T is the set of 1, 2, 3, 6, and 7, and W is a set of 1, 3, 9, and 10. List the members of the set T or W and T and W. So the members of the set T or W is 1, 2, 3, 6, 7, 9, and 10. And the elements of T and W is 1 and 3. Is it true that 5 is not in T? Explain your answer fully. Well, no, it is not in T, as you can see here. So, no. So, yes, it is true that 5 is in T. Question 5. If E is rabbit, cat, dog, emu, turtle, mouse, aardvark, and H is rabbit, emu, mouse, and J is cat, and dog, list the members of not H. So the members of not H are cat, dog, turtle, and aardvark. List the members of not J. So the members of not J are rabbit, emu, turtle, mouse, and an aardvark. List the members of not H and not J. So the members of not H and not J are basically rabbit, cat, dog, emu, turtle, mouse, and aardvark, which is basically E. What is H and J? Well, it is an empty set because there's no members in H and J. 5, not H. Well, not just means yes, so it's just H. Rabbit, emu, and mouse. What is H or not H? H and not H. So if you combine those two together, you just get the whole entire set. Everything. So it's just E. Rabbit, cat, dog, emu, turtle, mouse, and aardvark again. So that's the end of this video. Thank you and goodbye.